All right, here's going to be our Unit 4 test review. So number 1 says the table shows a child's height at different ages. What is the child's average rate of growth per year over the time period? Okay, so average rate of change we know is slope. All right, so we're looking for the slope here. Okay, I know slope is rise over run. It is also going to be, slope is going to be equal to change in y all over change in x. Okay, we're presented with a table, so that's the slope formula that we are going to use there. All right, so I've got to find the differences given here. All right, I know that age in years is going to be my x and height is going to be my y. So I've got to find the change in x and the change in y here. All right. So the difference to go from 1 to 4 years is going to be plus 3. And to go from 28 to 43 is going to be plus 15. You can just plug that into your calculator to figure that out. Now I've got to plug that into my slope formula. I know that's change in y, which it presents over here. So I get m is equal to 15 inches. Okay, that's my unit for y. All divided by my change in x, which is going to be 3 years. Okay, 15 divided by 3 can be simplified. If I divided each of them by 3, I would end up getting 5 inches per 1 year. All right, so this kiddo grows 5 inches every 1 year. All right. On number 2, it says find the x and y intercepts. All right, x and y intercepts there. So I have my x-intercept, which I know is when we set the opposite, which is y, equal to 0. And I'm also going to look for my y-intercept, which is when I'm going to set the opposite, which is x, equal to 0. All right, I'm going to solve for my x-intercept, solve for my y-intercept. So because I see that x and y are on the same side, all right, I could use the cover-up method. So that would mean for my x-intercept, I cover up y, so I would just get negative 2x equals 8. All right, but I'm going to go ahead and show you plugging in my 0 just so you can see it done that way as well. So I rewrite this and I set y equal to 0. I get 4 times 0, because I'm plugging that in for y, minus 2x equals 8. All right. I know that anything times 0 is just 0, so that's kind of that cover-up method. That's why it goes away, all right, in standard form there. So I get negative 2x equals 8. All right, now I've got to solve for this. So I have negative 2 times x. I divide by negative 2 on each side, and I end up getting x is equal to negative 4. Okay, I just simplified that down. So if x is equal to negative 4, my x-intercept is going to be negative 4, so that's my x place, comma 0. I know that it's 0 because we set y equal to 0. That is my x-intercept. All right, we're not done yet though, because now we're going to find our y-intercept. So on this one, I'm going to set x equal to 0. So once again, I'll basically do the cover-up method. All right, I'd have 4y equals 8. But I'll go ahead and work it out for you the long way. So I have 4y minus 2. I set x equal to 0 equals 8. All right, this all goes away because anything times 0 is always 0. So I end up getting 4y equals 8. All right, 4 times y. So I'm going to divide by y, but divide by 4, I'm sorry, because I'm doing the opposite there. So y is going to be equal to 8 divided by 4, which is going to be 2. All right, I've got to remember I've got to write this in coordinate form. So I have the y-intercept as 0, comma 2. Okay, we put 0 in the x place because that's what we set x equal to. All right, so because this is standard form, okay, x and y are on the same side, I can use the cover-up method. So when x and y are on the same side, use the cover up method. All right, when x and y are on the same side of that equal sign, just like we have here, we're going to use that cover-up method. So for x-intercept, I'd cover up y, and for y-intercept, I would cover up x. All right, you can see we ended up getting that anyways when we worked it out the long way. All right, so now moving on to number 3. Number 3 says y varies directly. Okay, it varies directly, which means I am going to have direct variation. Okay, so this is a direct variation problem. So I'm going to set it up like a proportion. All right, on top of my proportion, all right, I'm going to put A, and on bottom I'll have all my B's. Okay, so when I set up my proportion, it says if A is equal to 2, okay, then B is going to be 14. So I'll have 2 over 14. Okay, I made sure that 2 goes with A and that 14 goes with B. Now it says find B, so I do not know what B is when A is equal to 6. Okay, so A is equal to 6 there. All right, so I have 2 over 14 equals 6 divided by B. All right, so now I keep moving on. I've got to do cross multiply and divide. So I end up getting 2 times B, which will just give me 2B, equals 6 times 14. Okay? So now I've got to simplify this. I have 2B equals 6 times 14 is going to give me 84. All right, I got to keep simplifying this all the way down. I have 2 times B, so instead of multiplying, I'm going to do the opposite, which is going to be divide. And B ends up equaling, okay, I do 84 divided by 2, which gives me 42 there. Okay, so B is going to be equal to 42. Okay, we can go ahead and check our answer in our calculators. So what I'm going to do is I'm going to do 2 divided by 14. So I have 2 divided by 14, which gives me that number right there. Then I'm going to test my new number that I got with that 6. So I have 6 divided by, okay, instead of B, I'm going to put 42. Okay, I get the same exact answer, so I know that I correctly did this direct variation problem. Okay, I double checked my work. My answers are the exact same there. All right, so that is for number 3. Now let's go ahead and read through number 4. It says, according to Hooke's law, the distance that a spring will stretch varies proportionally to the amount of weight added to it. If a spring is stretched 0.75 inches by a 25-pound weight, how many inches will it be stretched by a 10-pound weight? Okay, so I have varies proportionally. That means this is going to be a direct variation problem. Okay, anytime I have proportionally, okay, that's going to be direct variation there. Okay, so it's going to be similar to what we just did in number 3. So I'm going to set up my proportion. Blah, blah, blah equals blah, blah, blah. All right, on top I'm going to put inches, and on bottom I'm going to put pounds. All right, so for the first part, I have 0.75 inches. So 0.75 inches when it is a 25-pound weight. And we're going to figure out how many inches it'll be stretched by a 10-pound weight. So we're going to go and throw a variable in there, okay, to show our weight, how many inches it will be stretched, all right? So I'm going to we'll just throw in y, okay, because I know that when I'm doing direct variation, it's a y over x. So it's going to be y over 10, okay? So y over 10 there. So now I'm going to do the same process we did on number 3. I'm going to cross multiply and divide. So I end up getting 25 times y, which is just 25y, equals 0.75 times 10. All right. I've got to simplify this. 25y is going to be equal to, if I do 0.75 times 10 in the calculator, you'll get 7.5. All right. I have 25 times y, so now I've got to divide by 25 on each side, because I am solving here. So y becomes, okay, if I do 7.5 divided by 25 in a calculator, I get 0.3. Okay, I want to make sure to put my units in this one because this problem does include units, unlike our last one. So 0.3 is going to be for y, which is going to be inches there. Okay, so our missing value is going to be 0.3 inches. All right, 0.3 inches. All right, now we're going to go and move down on to number 5. There we go. So number 5 says the function y equals 0.75x plus 5 models the cost in dollars y spent to buy and ship x notebooks. How much does the total increase for every notebook bought? All right. So it's talking about a total increase. All right. That is going to be our slope. Okay, for every single book, what does that look like? All right. So I know that this format given is y equals mx plus b, which is our slope-intercept form. Okay, y equals mx plus b. When we're talking about slope-intercept form, I know that m is always represented by slope. And that in this case, okay, because it's slope-intercept form, b is going to be our y-intercept. Okay. So m is always equal to slope, and b is going to be our y-intercept when I'm talking about slope-intercept form. So on this one, it says, how much does the total increase for every notebook bought? All right. So I've got to compare these equations. I see that 0.75 is in front of x, just like my m is in front of x. So m is going to be equal to 0.75. So our slope is going to be 0.75. All right, so that means every single notebook is going to be worth 75 cents because my shipping is $5 there, okay? So 75 cents is how much every single notebook is going to be, all right? Now on B, it says, what is the y-intercept and what does it represent, okay? The y-intercept and what does that represent? So I know that this 0.75 is the cost. So I'll write 75 cents per notebook. Okay, that's what our slope represented. Okay, that's the cost per every one notebook. Then, so it says, what is the y-intercept? Okay, I know that's going to be our b. So b here is equal to 5. All right, so our b is equal to 5. So what does that represent? That's going to be $5 for the shipping, all right, for shipping. Because I know that the $5 is going to be what's standard because every single notebook, which I know is X, is going to cost 75 cents, all right? It's not going to be $5 for one notebook and then you pay shipping multiple times. Instead, it'll be the cost for each different notebook plus that $5 in shipping. All right, so that's that one broken down for you. Now let's go and look at number 6. It says, based on the table, between what years did the town's population increase at the greatest rate? Okay, so increase at the greatest rate. So once again, this is going to be a slope problem. Okay, and like up above, I know that slope is going to be my change in y over change in x for a table. All right. So I've got to go through and find the changes, all right, in all of these. So I know this is my x and this is my y. So I have my change in x here and my change in y down here. All right. Now I've got to find the differences between each one of these. Okay. So if I plugged in 1996 minus 1992 in a calculator, I would get plus 4. And in 1999 minus 1996, I would get plus 3. 2000 minus 1999, I would get plus 1. And 2002 minus 2000 would give me plus 2. All right, I'll follow that same pattern. If I did 4,400 minus 2,800, I would get plus 1,600 there. If I did 5,000 minus 4,400, I would get plus 600 there. 5,000 minus 5,000 would actually give me plus 0. Okay, and then 6,500 minus 5,000 would give me 1,500 or 1,500. All right. So now I find the differences for all of these. So now I've actually got to find the slope. So I've got change in y all over change in x, just like my equation has here. So I use the two that correlate together, and that's what I'll do the whole entire way. So my slope for this very first one will be 1,600 divided by 4. Okay, the next one will be 600 divided by 3. And I continue that pattern. I've got 0 divided by 1. Got 1,500 divided by 2. Okay, so I've got 1,600 divided by 4 there, which is going to give me 400. All right, 600 divided by 3 is going to give me 200. 0 divided by 1, I know it's okay to have a 0 on the numerator, so that's just going to be equal to 0. And then I have 1,500 divided by 2, which is going to give me 750. I said that wrong. So now I've got to look at all of these different slopes that I have here, okay? So 400, 200, 0, and 750. So I know that 750 is going to be my greatest increase. So to answer the problem, the greatest increase is between 2,000 and 2,002, where my brackets are. All right, so the greatest increase is between 2,000 and 2,002. And we're going to keep moving on, okay? Keep moving on. All right. So the next one, which I just covered up, says Sam gets 150 pieces of candy for Halloween. The graph shows how much candy he has after X weeks. Okay, so now this X axis here is number of weeks, and the Y is going to be amount of candy. A says find the slope of the line and tell what rate the slope represents. Okay, so we've got to find the slope of the line and say what that rate even means. So I'm going to use my slope formula, which I know is m equals y2 minus y1 all over x2 minus x1. Okay, I know that it's change in y over change in x, which for slope, which is represented there. Okay, so I'm going to use the points given to me. All right, so I've got x1, y1, x2, and y2. All right, I've labeled those points to help me out. So now I plug in y2, which is 50, minus my y1, which is 100, divided by x2, which was 4, and my x1, which was 2. So I get 50 minus 100. Okay, if I plug that in my calculator, I'd get negative 50 on top. And then I have 4 minus 2, which gives me 2 there. All right, I can simplify this further. All right, so I simplify it. If I divided this, I'd get negative 25 all over 1. All right, so negative 25 all over 1. I know that my y, okay, my numerator here is represented by the amount of candy. So I've got number of candy pieces. On bottom, it's the number of weeks. So what this tells me is that for every 1 week, he is eating 25 pieces of candy. I see it's negative, so he is eating those. They are disappearing. So we're going to write this so now to explain what it is, so Sam eats 25 pieces of candy every week. Okay, and I know that's week, which means it's singular, which means it's just one there. Okay, now we look at B. It says find the x-intercept and tell what it represents. So I know that my x-intercept, okay, is what we've got to discover. So I know my x-intercept is whenever my line crosses my x-axis. So I see right here is going to be that point, all right? So I see it goes over 2, 4, 6. So I know this is 6, comma, okay? If on my y-axis I'm at 0, I will write 6, comma, 0, okay? So that would be my x-intercept there, all right? I know that 6 is going to represent the number of weeks, because that is my x-axis label. And then my y is going to be the amount of candy, or number of candy pieces is what I wrote. Number of candy pieces. So it says tell what it represents. So what this tells me is that he has 0 pieces of candy left, all right? So at 6 weeks, because that's how much time has passed, Sam, our character, will have 0 pieces of candy left. Okay, so I'll go ahead and put a box around my answers for this problem. All right, there we go. So that is that number 7 completely broken down there. All right, I'm going to go ahead and shift my page up a little bit. On number 11, we have similar questions here. Okay, on number 11, it says, what is the slope and what does it represent? Okay, so once again, I know slope is going to be change in y all over change in x. All right, so I've got to find my change in x, which I know is going to be up top, and my change in y, which is going to be on bottom. It's a table, so that's how I'm going to solve this. So to go from 1 to 2, I'm adding 1. To go from 2 to 10, I am adding 8. 1 to 3, I'm adding 2. And from 3 to 19, I am adding 16 there. Okay, so I've got to go ahead and check both of my slopes that I'm given. So the first one, I have m is going to be equal to y, my change in y, over my change in x. So I have 2 divided by 1. All right, that's as simplified as I can get that. 2 divided by 1 is just 2. I've got to check my other one. So I get m equals, I have 16, which is my change in y, divided by my change in x, which is 8. Okay, if I was to simplify that down in a calculator, 16 divided by 8 would just give me 2 over 1. All right, so I see that they're the same there. All right, we have verified that. So 2, my y value, it says is going to represent the cost in dollars. So cost in dollars. All right, on bottom, it's the number of tacos. Number of tacos that are purchased or bought. Okay, so what this tells me is that for every 1 taco bought, it costs $2 with the discount. So Sally will spend $2 on every 1 taco that she purchases. Okay, so Sally will spend $2 on every 1 taco that she purchases, which just tells me that every single taco is $2. All right. So it says, what is the y-intercept? Why is it negative, and what does it represent in this situation? So I've got to find my y-intercept. Okay. In this table, they don't give me a y-intercept though. So I've actually got to figure out what that is. All right. So I'm going to go ahead and add to my table here. I'm going to add in a column. All right. I've got to figure out my y-intercept, which I know is when x equals 0. So I'm going to set x equal to 0. Okay. Here I was adding. So in order to go backwards, I'm going to take away. So to get from 1 plus 1, I got to 2. Instead, I'm going to do 1 minus 1, which gets me to 0. Okay, I'm going to follow that same pattern. So if I have 1, all right, here, I'm going to subtract 2. Okay, because here I added, so now I'm going to subtract, which gives me negative 1. All right, I went backwards. Instead of adding 2, I subtracted 2. 1 minus 2 gives me that negative 1 there. All right, so my y-intercept, which is when x equals 0, is going to be right here. All right, so I have 0, comma, negative 1. 0, comma, negative 1. All right, and the reason it is negative is because of the coupon. So it is negative because of the coupon. Okay, it says, what does it represent in this situation? Okay, what it tells me is that the coupon is worth $1. Okay, because that's telling me they're giving me $1 for free. So the coupon is worth $1 because at 0 tacos, they would owe Sally $1. Okay, so if she buys 0 tacos, it shows them owing her $1 there. So the coupon is worth $1 because at 0 tacos, they would owe Sally $1. All right, and I know that it's negative because of that coupon. All right, that's that connection there that we have to make. Okay, so now we're going to go and work on number 12. Keep moving on along. So number 12, it says, given the table below, does y vary directly with x? So I know that this is a direct variation problem. So direct variation. All right. So whenever I do direct variation, I know that my equation, my constant, okay, or slope, whatever you would like to call it, is going to be y over x. All right. So that's what I've got to solve for here, y over x. So I'm going to take my y value, which is 20, and put it over 5 for the first piece. So I get k equals y over x, which in this case is going to be 20 over 5. Okay, I know that 20 divided by 5 is actually going to be 4 there. All right. Now I've got to keep going with that same process. I've got k equals, I have 28, my y value, divided by 7. 28 divided by 7 is going to also give me 4. Okay, I keep going. I've got 44 divided by 11. So k equals 44 divided by 11 there. I know 44 divided by 11 also gives me 4. Okay. It also gives me 4. All right, so I see that my constant is all going to be equal to 4. All right, in order for it to vary directly, it not only has to have a constant, okay, variation there, but it also has to go through the point 0, 0. So I've got to check at the point 0, 0. Okay, I can do that by plugging in a proportion. I know that when y is 20, x is going to be 5. Okay, so I could plug in a 0, okay, and solve for the other piece. So if I plug 0 in for x, I could just solve for y. All right, we're going to check the point 0, 0. So I plug that in here. I get 5 times y, which is just 5y, and I get 20 times 0. Okay, I know 20 times 0 is just going to give me 0, and on the other side I still have 5y. All right, in order to simplify this out, I have to divide by 5 on each side, so y ends up equaling 0. So my x was 0 and my y was 0, means it does go through the point 0, 0. All right, we just proved it, just double checked it. All right, so yes, it is a direct variation problem. Okay, we justified that. We showed that it is a constant, okay, variation there. All of them are 4s. And we also checked the point 0, 0. We have to make sure it goes through the origin. So yes, it is a direct variation problem. All right. I'm going to go ahead and keep going here. Got a couple more examples to make it through. All right, we're way over halfway done. All right, let's finish our way through this review. All right, here we go. On to the next. Number 13, it says, identify the x and y intercepts. What do they represent? So it tells me what I'm looking for, and it also says I've got to write what they represent. So for x-intercept, I know that is when y equals 0. For y-intercept, I know that is when x equals 0. Okay, remember it's that opposite there. All right, so now I go in and look at my graph. Okay, for x-intercept, okay, that's going to be where my line crosses the x-axis. I see that is at 16, 0. So my x-intercept here is 16, 0. My y-intercept, I know, is where the line crosses my y-axis. So I look, that point appears to be at 0, 59. Okay, so we've labeled our x-intercept and our y-intercept, all right? So now it says, what do they represent? Okay, so my x-intercept, I have 16, 0. I've got to use my x and my y labels to help me out with this. So it says it's altitude in thousands of feet, okay? So I'm going to work with the 16 first. So at, it says in thousands of feet, so at 16,000 feet, okay, that's what that 16 represents, the thousands of feet. So at 16,000 feet, all right, I know my y, so we're going to talk about the temperature. The temperature, all right, is, all right, I see that as 0 degrees Fahrenheit. 0 degrees Fahrenheit. All right. Now I'm going to write the other one. All right. So I know my 0 on my x represents thousands of feet. So at 0 thousands of feet, or just 0, at 0 feet, all right, the temperature okay, is going to be at, I go all the way up, I look, 59 degrees Fahrenheit. Is 59 degrees Fahrenheit. All right, so I broke down using my x and y labels what my x and y intercept means. Okay, so those are going to be my answers there. All right, on to number 14. Number 14 says, your family is driving from Cincinnati to St. Louis. The graph relates your distance from St. Louis, which is y in miles, and travel time x in hours. It says, interpret the x and y intercepts. Okay, I'm going to work that out over here. Okay, so I've got x and y intercepts. So I've got A. All right, I have my x-intercept. And I also have my y-intercept. All right, I've got to solve for both of those things here. So I've got to use my graph to help me out. So my x-intercept is when my line crosses the x-axis. So I go and look here. I have 1, 2, 3, 4, 5, 6, comma, 0. Okay, so my x-intercept is going to be 6, 0. All right, do the same thing with my y-intercept. I know it's where my line crosses the y-axis. I go and look, and it is at 0, 360. Okay, so 0, 360. All right, now I've got to use my labels to help me decipher what this means. Okay, figure out what this means. So at 6, all right, that is going to be at 6 hours. So at 6 hours. Okay, at 6 hours. All right, my 0 is the distance from St. Louis. So at 6 hours, the family still has 0 miles left to travel. I should knock out that still. It should say at 6 hours the family has 0 miles left to travel. I'm going to get rid of that still there. Sorry. I was thinking of the bottom one. All right. So now I've got to do the y-intercept. So instead of the 0 representing the distance here, now it's going to represent my time in hours. All right. So for this, I've got at 0 hours, the family, now I can use my word of still has 360, that's what my y is here, 360 miles left to travel. Okay, so that's what my x and y intercept represent there. All right, when we've gone 0 hours, that means we haven't gone anywhere. We still have 360 miles to travel. All right, for my x-intercept, okay, it started at 0. I go all the way to 6 before I finally arrive. That means it took 6 hours to get there, to finally have 0 miles left. All right, keep moving on. On to number 15 here, okay? So number 15 says identify the x and y intercepts. Okay, so I'm going to keep, oh, I forgot B over here. Just kidding, going back. All right, on number 14, B, it says what is the slope? What does the slope represent in this situation? All right, so what is the slope and what does the slope represent in the situation? All right, I know that slope is going to be y2 minus y1 and x2 minus x1 because I have points given to me. All right, there are points there. So my points that we used earlier, I have 0, 360 and 6, 0. So I label those. I have x1, y1 and x2, y2. All right, so I plug those in. I have 0 minus 360. So I've got y2 minus y1 all over x2, which is 6, minus x1, which is 0. So I do 0 minus 360, which is going to give me a negative 360, divided by 6 minus 0, which gives me 6. All right, I've got to simplify this further. Okay, if I did negative 360 divided by 6 in a calculator, I would get negative 60 there over 1. Okay, so I got to figure out my x and y labels. So now my time is my x on bottom, so that's going to be in hours, and my top is going to be miles. All right, so what my slope tells me is that for every 1 hour, the family has 60 less miles to go than before. Or you could think of it as every 1 hour the family travels 60 miles. Okay, it means I'm getting 60 miles closer to my destination. Okay, so written either way is okay with me. All right, moving on. Number 15. We're getting close to being done. All right, identify the x and y intercepts. So I have x-intercept right here. And I have y-intercept. All right, so my x-intercept, if I look at my graph, is going to be when my line crosses the x-axis, which is going to be at 10, 0. And my y-intercept is going to be where my line crosses the y-axis, which is going to be at 0, 1,000. Okay, so now I've got to use this situation to write and explain what it represents. So it's talking about a laptop loan. Okay, it's the number of weeks on my x by the amount owed in dollars. Okay, so if I look at 10 weeks here, okay, it says I owe $0. All right, because my x is at 10 weeks and my y is at 0 here. So at 10 weeks, the customer or the person will owe, okay, at 10 weeks they will owe $0 on their laptop. Okay, their loan will be paid off. All right, now let's look at the opposite side of that. So I know the x represents number of weeks, so at 0 weeks, the person will owe, okay, at 0 weeks it says they owe $1,000. That's a 0, sorry. On their laptop. All right, so that's my x and y intercepts there. That's what they represent. All right. Moving on to the last and final page. All right, here we go. We did some graphs. Now we've got some tables here. All right, we have already worked out the graph problems. So number 16, it says identify the rate of change of the following table and determine if its situation represents a line. Okay, so rate of change, which tells me it's going to be slope, because I know that slope is the rate of change. All right, and I'm given a table, so I know that my slope is going to be change in y all over change in x. All right, so now I've got to find the differences. Okay, so I'm going to draw all my brackets here. All right. So I go from 0 to 1, I'm adding 1. From 1 to 2, I'm adding 1. 2 to 3, I'm adding 1. And from 3 to 4, I'm adding 1. To go from 9 to 7, I'm actually subtracting 2. 7 to 5, I'm subtracting 2. 5 to 3, I'm subtracting 2. And from 3 to 1, I am subtracting 2. All right. If you look, all of the differences are the exact same, which means that it is a constant rate of change. So for my slope, I plug my change in y over my change in x. So my change in y is -2, divided by my change in x, which we see is 1. So yes, okay, because my rate of change is constant, it represents a line. Okay, so yes, the table presented is a line because it has a constant, you can either write rate of change or slope. So it has a constant slope. okay, or a constant rate of change. So yes, the table presented is a line because it has a constant slope. All right, keep on going. Number 17, the table shows the height of a pine tree at each of 2 ages. What's the tree's average rate of growth, okay, which I know is going to be slope as well, during this time? So I have a table, so I have m equals change in y all over change in x. Okay, I've got to find my differences just like we did above. Okay, so I draw my little brackets there. To go from 2 to 10, I added 8. Okay, to go from 6 to 9, I added 3. Okay, I know that my age in years is going to be my x, my height is y. So over here is my change in x, and over here is my change in y. Okay, I'm labeling those so I don't forget. So now I've got to plug it into my equation. I get m equals my change in y, which I see is 3, all over my change in x, which is 8. Okay. Because this one presents me with units, I need to go ahead and use my units, all right, because I've got to write down this slope, all right? It's a little bit different, all right, than the above one, but it's pretty similar. So the one above would have been my height in inches all over the hours. Well, here it's going to be y, which it says is height in meters, over my years there, okay? So if I was to write this out in a way for somebody else to understand, I could say for every 8 years, the tree will grow, because that's a positive number, will grow 3 meters. Okay, for every 8 years, okay, the tree will grow 3 meters. All right, got one more problem left and we are done. Here we go. So, number 18, it says the table below shows the change in snake population over a period of years. When did the snake population decrease at the greatest rate of change? Okay. So I've got greatest rate of change, means I'm talking about slope, that rate of change that we'll constantly hear about. It's once again a table, so I have m equals change in y all over change in x. My years represented by x, my number of snakes is y. Okay, so that one doesn't label it for us. So now I've got to find the change between all of these. Okay, this one's very, very similar to number 6 that we've already worked out. So I've got to find my differences, and to do that I use my brackets. So I go from 1998 to 2000, I'm adding 2, okay, because this is my change in x. To go from 2000 to 2003, I'm adding 3. To go from 2003 to 2004, I'm adding 1. 2004 to 2006, I'm adding 2. All right. Then for my change in y, which is my number of snakes, I decrease by 4 here. Then I decrease by 10. Then I decrease by 2. And then I decrease by 9. All right. But it's asking for the greatest rate of change. So I've got to find all of these different slopes and compare them. So I start here. I have m equals my change in y over my change in x. So I get negative 4 divided by 2. Okay, keep going with that process. I get negative 10 divided by 3. M equals negative 2 divided by 1. I get m equals negative 9 divided by 2. Okay, if I'm looking at what's presented, that's a little difficult to figure out just by looking at those fractions. Okay, instead what we can do is we can plug them into our calculator and see what we get when we simplify. So on the first one, I have negative 4 divided by 2, okay, which gives me negative 2. So I'm going to say that is equal to negative 2. All right, on the next one, I have negative 10 divided by 3. So I've got negative 10 divided by 3, which gives me negative 3.33333 repeating forever. So I get negative 3.33. Okay, I have negative 2 divided by 1. Okay, negative 2 divided by 1 is just going to be the same thing because anything divided by 1 is just itself. And then for the last one, I get negative 9 divided by 2. Negative 9 divided by 2, which I get negative 4.5. Okay, now I have these mixed numbers. It's a lot easier to compare. So it says I'm looking for the greatest rate of change. Okay, so I have negative 2, negative 3.33, negative 2, and negative 4.5. I see that that is going to be the greatest change. So the greatest rate of change is between 2004 and 2006. All right, and that would be my final answer there. All right, that is the whole entire review worked out. Okay, if you still need help on these problems, feel free to go watch the other videos in our Google Classroom. Okay, or remember on YouTube you can search Coach Madeline Wood. Thank you.